For our last strategy, take a look at this equation here. So notice that instead of having an x here, we have a 3x. We have some sort of multiple of our angle. But really, who cares? Let's ignore it for right now and just substitute our favorite variable, like k, in the place. So I have 2 sine k equals 1, where k is equal to 3x. We'll just ignore that right now. Anyway, so solve this thing for k. Solve it for k. K should be equal to pi over 6 plus the period. That's because on the unit circle, sine is equal to half, right there at pi over 6, and then add the period. So now what we have to do is we have to unsubstitute that k, if that's even a word. Anyway, so it's not really k, it's supposed to be 3x. How do I get rid of this 3? I have to divide both sides by 3. When I divide pi over 6 by 3, I get pi over 18. When I divide the period by 3, I get 2n pi over 3. And of course you'd have to do that to the other set of solutions to just n. Let's try it on this equation. Let's ignore this 2k, or this 2x, make it a k. So sine k minus root 3 over 2 equals 0. Solve this thing for k. Sine k equals root 3 over 2. On the unit circle, sine is equal to square root of 3 over 2, way up here at pi over 3. So k equals pi thirds plus multiples of the period, 2n pi. But it's not really k now, is it? No, it's 2x. So let's put 2x back in its place. And how do I get rid of this 2? I have to divide both sides by 2. Pi over 3 divided by 2 is pi over 6. When I divide the period by 2, it just gives me n pi. There's the first set of solutions. Do the same thing. Sine is also equal to root 3 over 2. Over in quadrant 2, that's 2 pi thirds. So k equals 2 pi over 3 plus the period, but not really k, it's 2x. To get rid of the 2, divide, just like we did before. On the first term, the 2 will cancel out on the top and just leave pi over 3. And then on the period, the 2 will cancel again, leaving n pi. There's the other set of answers. Let's see if we have time for one more exercise. On exercise 11, let's get rid of this and make it a k. Tan k minus 1 equals 0. So tan k, or tank, equals 1. Tank is equal to 1 at pi over 4. Right. So k equals pi over 4 plus n pi. And remember that takes care of the one over here in quadrant 3, which is at 5 pi fourths. Not really k now, is it? It's supposed to be x over 2. This time, to get rid of the 2, I'm going to multiply both sides by 2. So x should be equal to pi halves plus, when I multiply this by 2, I get 2n pi. There's the whole set of general solutions. Very nice. And now get busy on a little bit